Hey guys, Mr. Black here, and I'm going to be talking to you guys today about impulse. So let's go ahead and get started. So we've been talking about momentum. You guys should have heard a little bit about momentum last time we met, right? We were talking about how momentum is the mass of an object times the velocity that object is going, right? So that's how much momentum something has, is how big it is, and how fast it's going gives you its momentum. Well, today we're going to be talking about impulse, which is kind of similar to momentum, but it varies in a few ways. It more deals with the time aspect versus the speed aspect, right? So let's look here. We've got impulse is the change in the momentum of an object due to a force that is applied during a period of time. So it's usually represented by the symbol J, and the equation that we'll typically use for impulse is that it's equal to the force of an object times the amount of time that object is experiencing that force. Okay, so we've got our units are going to be newtons times seconds, because we've got the equation is force times time. But impulse, it's got those two variables, right? Force and time. So when we adjust the amount of time that a force is acting on an object, that plays a huge role in this. So we apply a force over a long period of time. For instance, when you're playing golf or you're pushing a car, that's going to create a large impulse because we've got an extended period of time but a small force. So on the flip side of that, if we apply a large force over a short period of time, we'll get the same impulse, but it'll happen more instantaneously, right? So if you ever watched karate, the guy comes down with a massive karate chop. He hits all those bricks, but he does it in a split second. So we had a really small time there, and that's going to create a really large force, and that's going to give us a large impulse as well. So there's two different ways we can get that large impulse. This is actually why we have airbags in our cars, because when we crash, that airbag comes out and is supposed to increase the amount of time that we're experiencing that force, and that's going to hopefully decrease the force that we're feeling from the impact, and then that's going to protect us, right? Same thing for the crumple zone in a car. The car crumples, and the reason that we've got that crumple is it's trying to increase the amount of time so that we can decrease the force that the car is experiencing from that crash. Because the less time that we're experiencing that force, the bigger the force is going to be. And that's one of the basic principles of impulse. All right, so let's keep cruising. Let's look at a problem here with impulse. Okay, so we've got a football player kicks a ball with a force of 50 newtons. Find the impulse of the ball if his foot stays in contact with the football for 0.01 seconds. Right, so we'll use the guess method here. So we've got our givens in this problem. We've got the force of 50 newtons, and we've got the time of 0.01 seconds. The unknown, it's asking us to find the impulse, right? It tells us right there to find the impulse. So we know that we're going to use that equation that we just learned. Impulse is equal to force times time. And then we're going to substitute those numbers in for force and time, and then we're going to multiply them together, and that's going to give us our impulse there. Okay, so that one's a pretty easy type of a problem, right? It's pretty straightforward. There's only a few variables there. So now we need to talk about the impulse momentum theorem. So impulse theorem is talking about how impulse is equal to a change in momentum. So those two things are equal. So if we know that our impulse is the amount of force that an object experiences over a certain amount of time, then we know that force experienced over a certain amount of time is equal to the mass of an object times the change in velocity of that object. So we know that momentum is equal to mass times velocity. Well, change in momentum is mass times a change in velocity there, right? Because the mass of an object typically is not going to change. Okay, so we've got a couple of methods of getting the same change in momentum. So if we experience a large force over a short period of time, for instance, if a car runs into a brick wall, for instance, that's going to be a large force over a short period of time. and that's going to do a lot of damage, right? There's going to be high stress on the object. There's going to be a large amount of deformation there in the car. But if we have that same example over here, then what we should be able to do is to see. Let's see if I can move this real quick. Yes. Okay. So in this side, we've got a small force over a long period of time, right? If we run our car into a bale of hay, there's not much force there, but we're feeling it over a longer period of time because we're going through this entire haystack. So it's the same impulse, the same change in momentum, but there's going to be less stress on the object and there's going to be less deformation because we're experiencing it over a longer period of time. So we get the same change in momentum. It just in both of these examples, it's just that we change the amount of force in one and then we change the amount of time in the other. Okay. So let's look at a problem that deals with this impulse momentum theorem. Okay, in the equation that we have with it. So we've got a 0.5 kilogram baseball experiences a 10 Newton force for the duration of 0.1 seconds. It's asking us what is the change in velocity of the baseball. So we need to use our guess method here again. What are our givens? Well, it looks like they gave us the mass here of the baseball. They gave us the force that the baseball is experiencing and the amount of time that it's experiencing it. Okay, and it's the unknown. What it's asking for is that change in velocity. What is the change in velocity of the baseball? Well, based on all the stuff that we've been given here, the mass, force, time, and change in velocity, it would be a pretty good bet to use this impulse momentum theorem, that equation that we've been talking about here, because it's got everything that we need and what we're looking for in it. So we'll substitute out all of the variables with the numbers that we've gotten, and then should end up looking something like this. And then when we run that into our calculator, we should work out that math to be able to divide both sides by 0.5 here at the end, and then that should give us that our change in velocity is 2 meters per second there. Okay. So yeah, that's pretty much it. All I've got for you right now as far as notes goes. So you should be able to, by the end of this video, know how to work out problems, impulse problems that deal with force times time, work out impulse momentum theorem problems that use that equation that we just did right here. And then we should also be able to know the differences between change in time and force, how those two things are inversely related. Okay. You'll have some practice with that using an egg drop experiment today, as well as some practice with these problems, some calculations as well. If you have any questions, be sure to ask your instructor for physics. But otherwise, Mr. Black out.